Prime factorization, divisibility tests. A number is divisible by a smaller number if the small number divides into the number. We have some really nice divisibility tests that really help us find the prime factorizations for numbers. The first one is for 2. The divisibility rule for 2 is that it ends in an even number. For example, we're talking about 0, 2, 4, 6, or 8. If it ends in any of those, it's divisible by 2. 3 has a really nice divisibility rule in that if the sum of the digits is divisible by 3, then the number is divisible by 3. And 5, it either ends in 0 or 5. For 7, 11, 13, 17, 19, we just have to use long division. That's the only way to tell. So let's take a look at our examples. In example 1, we have 2,730 is divisible by which prime numbers? Well, I always start with the smallest, which is 2. And I can tell that it's divisible by 2 because it ends in a 0, which is an even number. It's also going to be divisible by 5 because it ends in 0. Let's check 3. So we're looking to see if 2 plus 7 plus 3 plus 0 is divisible by 3. 2 plus 7 is 9, plus 3 gives us 12. Since 12 is divisible by 3, we can say that 2,730 is divisible by 3. So it's divisible by 2, 5, and 3. Let's take a look at 133. It's not divisible by 2, and it's not divisible by 5, and I can tell that just by looking at the last number. It's not an even number, and it's not 5 or 0. So now we check 3. So I'll add up 1 plus 3 plus 3, which is going to give me 7. So 3's out. Now, it doesn't mean that it's not divisible by other numbers. Okay, I need to check those. So we're going to check our next prime number, which would be 7. And we have to use long division here. So we're looking at 7 going into 133. Well, 7 goes into 13 one time. There'll be 6 left over. 7 goes into 63 evenly. Actually, it's 9 times. So that means it's divisible by 7 and 19. Now, since 7 and 19 are prime, I can be pretty sure at this point that this is all the factorizations I've got for this. So 7 and 19 are my answers for example 2.